Good morning, my students. We are going to study the magnetic effect of the electric current. The magnetic effect of the electric current. When the current flows through the wire, the magnetic effect of electric current, when the wire current flows through the wire, it produces magnetic field in region around the wire. It's called magnetic flux due to the current passing through the wire. If you have a straight wire passing through a cardboard, this is a cardboard, and this wire connected with the terminals of the battery. This is the battery. This is the positive pole. The current transfer from positive to negative and go to the negative pole of the battery. And when we put iron fillings, this is iron fillings, and move the cardboard, vibrate it gently. What happens? We observe that the iron fillings are arranged in the forming of concentric circles, represented the magnetic flux lines. These lines is called magnetic flux lines. We can determine, this is the iron fillings. We can determine the direction of the magnetic flux by using compass. This is the compass, which used to determine the direction of the magnetic field. This is the first state. How can you determine the direction of the electric current? By using Ampere right-hand rule. If this wire carrying electric current, magnetic field is formed in the form of concentric circles. If the thumb points to the direction of the current, the other finger will point to the direction of the field. If this wire carrying electric current, and this is the number of magnetic flux lines, if the thumb up points to the direction of the current, the other finger will point to the direction of the field. This means that when the direction of the current is reversed, the direction of the magnetic field is reversed. This is the first state, is called magnetic effect of electric current. Magnetic effect of electric current may be in wire, in a straight wire, or in a coil, that showing iron fillings or compass on the cord way from the wire, the magnetic field weakens. This means that the magnetic field, when we go away the wire, magnetic field decreases. Concentric circles should be drawn farther apart. Below it, show different views of the two individual wires. The direction of the field is determined by right-hand Krebs rule. As a current is reversed, the direction is reversed too. Front view, if the thumb points to the direction of the current, if the thumb points in the current direction, other fingers will give direction of the field. magnetic field is in the form of concentric circles, in the form of concentric circles. And the left-hand side, the thumb up, other fingers points to the direction of the current. The thumb move down, other finger points to the direction of the current. And the first side, the direction of the field in anti-clockwise direction. And the right side, the direction of the field is clockwise direction. This field can be draw it in the form of concentric circles. The center point is the position of the straight wire. Is the position of the straight wire. And the direction of the current, the magnetic flux is in the anti-clockwise direction. At right, current into the page. Into the page. The left, current out of the page. The current is out of the page. Magnetic flux pattern due to current in solenoid. Solenoid like a spiral spring. Magnetic field similar to that power magnet. In the first state, when we use a straight wire, the magnetic flux in the form of concentric circles. While in case of solenoid, the magnetic field is similar to that of a power magnet, with the north and south pole at the ends of the solenoid. The direction of the field is determined by right hand grip rule. Right hand grip rule. Inside solenoid, the field is uniform. Lines of the field are parallel and equidistant. This means that it is uniform magnetic field. Different views of solenoid. Front view, this is the solenoid. The terminals of the solenoid connected with the battery. This is the north pole and south pole. The current, the field in this point move up, represented by dot. When the field move downwards into paper, into page, represented by cross. But the field is represented by north and south like power magnet. While inside it, represented by parallel lines and uniform magnetic field in completed magnetic field. In completed magnetic field. Determining the direction of the magnetic field. If the fingers point the current direction, the thumb will point to the direction of the field. The thumb will point to the direction of the field. This is called electromagnet. What is the meaning of electromagnet? Electromagnet, it is a magnet that operates when there is a current, when a wire is wound rapid around a piece of soft iron in form of bar or horseshoes. This form an electromagnet. If the current passes in the wire, the soft iron core becomes magnetized and we get a magnet. If current is stopped, soft iron core loses its magnetism, like this figure, in the form of horse magnet, or spiral spring, or soft iron core which concentrate magnetic flux, What are the advantages of the electromagnet? Number one, can be very strong, has adjustable strength, very force, can be switched on and off, not permanent, can reverse polarity easily by reversing the battery or reversing the polarity of the battery. Relay electromagnet. This is relay. If you have a motor connected with a battery and the plastic frame, a spiral spring metal contact, and armature, this metal is called armature pivot. Armature can attract to it or lose its magnetism. When the circuit is closed, it converts into electromagnet, attract armature. It is a switching device which make the use in one circuit an electromagnet operated by a small current to switch on another circuit operating device or machine by a much larger current. In this example, we observe that when a small current flow in the coil, the core becomes magnetized and attracts the armature. This is the armature. And contacts closed as a result, causing large current to flow to the electric motor. Here, when the switch is closed, the motor turns on through the action of relay. Now we have the lamp and the motor both operating together. The speed switch and read relay. Speed switch and read relay. Speed switch at first. It is a switch that operates by using electromagnetic effect. It consists of a glass tube with two iron reeds slid in it. Normally open reed switch. If the magnet is brought near reed switch, it magnetized the iron reeds so they attract each other and the current flow through it. If the magnet moves away, switch open again and reed switch like this, normally open on or normally open off. Like in this is open and this is closed, on and off. Normally closed reed switch. You can also get reed switch to work the opposite way. Two iron reeds are normally in contact with each other. If a magnet is brought near the reed switch, it magnetizes the iron reeds, so they repel one another. And the reed switch open, breaking the circuit. If the magnet brought near, switch closes again. Reed switch like this normally closed, normally switch. Example. Reed switch. This is the battery, electric bell. This is the magnet. Normally closed reed switch can be used in burglar alarm. The reed switch is fixed in the door tram, and magnet is fixed to the door. Opening the door would bring the magnet away from the reed switch, which connects the bell's circuit and triggered the alarm. Reed relay, if the switch is put inside a coil of the wire, an electromagnet, it can be operated by current in the coil, because when it is closed, the magnet becomes electromagnet. A small current in the coil, switch it on. Larger current in the relay switch circuit operating the motor, because electromagnet increases the magnetic field, so can be used to operate the electric motor. Goodbye and good luck, my students.